All right, what we're going to talk about today are intercepts and linear models. So first let's talk about our x and our y intercepts. Your x-intercept is the point where the graph crosses the x-axis, so your ordered pair is x0. So to find your x-intercept, you plug in 0 for y, and then you have your y-intercept. Your y-intercept where it crosses the y-axis at a point, and you plug in 0 for x to find the y-intercept. So what I like to do is I always like to make a table, and when I make my table, I know if I'm looking for my x, that's the x-intercept, so I just make the other one 0. And if I'm looking for my y, I just make your y-intercept and I just make the other number 0. So I make a little table just kind of help keep my ordered pairs in order and organized. All right, so first let's start here. It says to find the x and y intercepts. So as I'm following the line, I notice that it crosses the x-axis at this point, which is 2, 0. So that was pretty easy. And then now I look on my y-axis and I follow it along, and I see it crosses my y-axis at this point, which is 0, negative 2. So again, you start at origin, so when 2 and we didn't go up or down, so that's where we got that. And then here started the origin, we didn't go left or right, we just went down 2. All right, so this one, again, follow your line, look to see where it crosses. This would be the y-intercept, and then here would be the x-intercept. So write your ordered pairs for those. And then now let's figure out how to find this. All right, so if we were to look at our equation and we wanted to find the xy intercept without a graph, it's actually you're just subbing in 0 for one of the variables, and then you can find the other one. So again, I like to make my table just to help keep me organized. And I know if I'm going to look for my x, I'm just going to make the other number 0. So I wrote my equation, but instead of y, I'm going to make that y a 0. So I'm going to get 3x plus 2 times 0 equals 6. And then you'll end up getting 3x equals 6, divide by 3, and x equals 2. So since I used this up here, I was looking for my x, that's the x-intercept, and I know the other value was 0. So you're going to do the same thing, but this time we're looking for y, so that's your y-intercept, and you're just going to make the other number 0. So in this case, instead of x, I'm going to make x 0. So 3 times 0 plus 2y equals 6. So you get 2y equals 6. Divide both sides by 2, and you get y equals 3. So since we made x 0 here, that's going to go here, and then your y is going to be 3. So for number 7, same thing. If I'm looking for x, this is your x-intercept. You make y 0, which is what I did here. So if I'm looking for x, this is your x-intercept. So 4x equals 8. Divide both sides by 4. X equals 2. And then like we said, since we made that 0, you have to put that there. All right, so for the other one, you just switch it. So we're looking for our y, so we make the other variable 0, which is x in this case. So 4 times 0 minus 2y equals 8. Divide both sides by negative 2. And you get y equals negative 4. So remember, we made x 0 up here, so we have to put that here. And then y, we said, was negative 4. All right, I want you to go ahead, try that top part, and then we didn't graph them, but let me show you the graph. So for here, we said 2, 0, and 0, 3. So 2, 0, that's this one. And then 0, 3 is up here. So that's your graph, and then connect your points. And then here, 2, 0, so it's on the x-axis at 2. And then here is on the y-axis at negative 4, and then connect your points. All right, so make sure you complete all of that. Don't forget the graph. And then now we're going to talk about linear models in standard form. So remember, we said standard was the ax plus by equals c. So when you're doing this for word problems, it's important to use variables that work with the situation. In this case, it wanted you to use a linear model with x and y, but truthfully, if I were to have done this just to solve, I probably would have said C for child tickets and A for adult tickets, just to make sense with the situation. So I could have said 3C plus 7A equals 210. That's also another way to set it up, but always make sure you say what your variables represent. So children's tickets cost $3 each, so that's one rate. Adult tickets cost $7 each, so that's another rate. And we said adults were Y, children were X. So the total amount earned equals 210. So since we're earning both of it, you're adding equals 210. So that's your equation. And then it wants to know how many children's tickets were sold if 24 adult tickets, so remember we said adult tickets were Y, so we're substituting that into the Y here. So we'll get 3x, whoops. So remember we're doing 24 equals 210. So we're looking for x, and once you solve that, you're going to get x equals 14. So that 14 represents the children's tickets. All right, so go ahead, you're going to complete this problem, but it's important you tell me what x represents and what y represents. So think of the things that you're selling. So in this case, you're selling lemonade and you're selling candy. So one of these variables should be lemonade, and the other should be candy. Whoops, not candy. Whoops, candy. Now, I don't care if you were to use L for lemonade and C for candy. You can do that also. But I want you to go ahead, I want you to try this problem using your let statement and then solve the bottom. All right, linear function. So it's important to know when you're talking about a linear function, it's a straight line. So y equals mx plus b. We talked about m is the slope. That's how much you move. B is the y-intercept. So this is the y-axis. This is the y-intercept. So remember, your x term will be 0 for this. So you're going to begin the graph where your b value is. So we're going to go right here, and then your slope's going to tell you what to move. So since this is -1, that's your b value. And now I went up 2, but from here I went to the right 5. So remember, we said it's y over x, which is 2/5. So remember, when you're looking for the y-intercept on a table, look for where the x value equals 0. So that's what I was telling you before to keep you organized with the table. You know your intercept is whenever x equals 0. So knowing that, let's look here. It says write an equation for the following linear table. So first what I'm going to do is I'm going to find slope. So to get from 5 to 12, it's adding 7. To get from 12 to 19, also adding 7, and then plus 7, so on and so forth. So we know that our y for our slope is plus 7. And we know that our x, to get from here to here, we're adding 1 or increasing by 1. So we know that our x is 1. So that's going to simplify to 7. So when we got that, now we know to put that into here. And remember, it's always your slope times x. So your slope is always attached to the x. And then our y-intercept, well, remember, we just said that whenever x is 0, that's your y-intercept. So if you look here, isn't x 0? So we didn't even have to plug it in. We just looked at the table. And that's your final equation. All right, so I want you to go ahead. I want you to try that one. And then sometimes the y-intercept isn't on the table, so you have to find it. One way to find it is if you're really close to 0, you can work backwards on the table. So we know going this direction, we're subtracting 2, because that's your y's. So as we're going this direction, we're subtracting 2. But if I were to go backwards, I'm going to add 2. So let's just check here. Here I'm going to add 1 each time. So I know my slope is -2 over +1, which equals -2. So that's why I'm going to add 2, right? And this is really over 1. So if I'm adding here, if I go backwards, I'm going to subtract. So you're just going to count backwards. And so if you notice, you're going to end up at 0,9. So your slope is here, but again, your y-intercept is when x is 0. So you know your y-intercept is +9. So that's one way to do it. All right, so now we're going to talk about something new. It's arithmetic sequences. And for this is called an explicit equation. So you have a sub n is a the first term plus d times n minus 1. So a is the first term in whatever your sequence is, and d is the common difference. I kind of think of this as a rate. So, and I think of this as like my y-intercept or my b value. So when I kind of think of this as y equals mx plus b, I think of this as my b and I think of that as my rate. So it's kind of within there. Your sequence starts with your first term, and when you graph it, it's discrete. So you do not connect the points. You just leave them separate. All right, so that's one example. So to write an explicit equation, here's what you do. You have to figure out what the first term is. So we said a sub 1 is your first term in the thing. So in this case, it's 5. Now we need to find the common difference. So the common difference is just how much you're adding, subtracting to get from one to the other. So to get from here to here, I'm adding 2. So if you notice, it's always adding 2. So the common difference is +2. So now we're going to sub it in to this equation, where your first term plus your common difference, and that's the n minus 1 so you can find whatever term you want. All right, so now that I did this, now I'm going to distribute. So we have 2n minus 2 and bring down the 5. And I'm going to combine like terms to give me 3 and then bring down plus 2n. So I know it's simplified as 3 plus 2n. If I want to find the 25th term, all I have to do is just substitute in that value for n and go ahead and go 3 plus 2 times 25 because we want the 25th term. 2 times 25 is 50. So 3 plus 50 is 53. All right, this is similar. So you want to do an explicit equation. So you need to figure out what the first term is. And then you need to find the common difference. So to get from each number, you're adding 7. So put it all together. And then now we're going to distribute to get 7n minus 7 and bring down the 12. And then go ahead, combine your like terms, and then bring down the 7n. So now it wants to know if you have the 15th term, we're going to plug that in for n. So you take that and then add 5, you get 110. That's your answer. All right, I want you to go ahead and try that one, see how you do. And then that is your XY intercepts and linear models.